All right, so we're going to be looking at the second review sheet today, going through this, working through it, and then I'll be posting these online later today. So, test tomorrow. I'm going to need to know the finding missing angles from the two parallel lines cut by transversal, from triangles, some algebra proof. Over the proofs, you're going to have to fill in the reasons, so we're going to work towards that today. Okay, so take a look at the first one. So below the figure below, we have two parallel lines, L and M. So remember, we can throw those arrowheads on the two lines here. All right, it says A, so it's 6x plus 20, so we'll put that in the angle there. H is 9x minus 40. And we're going to find the measure of all 8 angles. Now remember, there's 4 angles that are the same. So we know that angle A is equal to, the measure of, is equal to the measure of angle B, which is equal to the measure of angle E, which is equal to the measure of angle H. And then we can state what that is. We also know that the measure of angle B is equal to the measure of angle C, which is equal to the measure of angle F, which is equal to the measure of angle G. And we'll find out what that is. So those 4 angles are equal. We talked about the 2 types of angles on this here, right? There's an acute angle and there's an obtuse. So these 2 obtuse angles would be equal. The acute and obtuse make 180. The acute angles are equal. All right, and these specific angles are actually alternate exterior angles. So the equation we want to make is that 6x plus 20 is going to be equal to 9x minus 40. So to solve, we'll move the 6x over to get the x's on the same side and make them positive. We'll move the 40 back over to the other side. We'll get 60 is equal to 3x. We'll divide it by 3, and we'll show that x is equal to 20. And then we're going to plug in. So it doesn't matter which one you plug in for. And a good way to check would be if you plug in 20, you should get the same thing here, okay? So 9 times 20 minus 40, that's 180 minus 40, and that's 120. And then 6 times 20 plus 20 is 120 plus 20, which again is 140. So the angle right next door to it is just 180 minus 120. All right, and that's 60 degrees. So these angles will be 60. These guys are 120. All right, and that'll be good to go. So angle A, D, E, and H are 120 degrees, and angle B, C, F, and G are 60 degrees. All right, and that's it. Number 2, this is supposed to be in triangle ABC. We talked about that in class. Okay. So angle A is x, so figure out like A, B, C, right? We have x, 2x plus 2, and then 3x plus 4. So the rule here is that all the angles are going to be adding to 180 degrees, okay? So x plus 2x plus 2 plus 3x plus 4 is going to equal 180 degrees. So combined like terms, we're going to get 6x plus 6 is equal to 180. We can take away the 6 from both sides. All right, and we're going to get 6x is equal to 174. We'll divide by 6, and x is equal to 29. All right, so now that I know what x is, it says find the measure of each angle. So angle A is just x, so it's 29. If we do 2 times 29 plus 2, that's 18, 58 plus 2, that's 60 degrees. So angle B is equal to 60 degrees. And then 3 times 29 plus 4, this is going to be 27. 2, 6, 87 plus 4, that's 91. And angle C is equal to 91. And if we add them together, we should get 180. So 29 plus this is going to give us 120, and then we have 60, that's our 180, so we're good to go. Okay? Angle 3, number 3 here, we have the diagram shown below. AC is extended through point D. Its measure of angle BCD is 6x plus 20, so 6x plus 20. And then I have BAC, which is 4x minus 5. And then I have x plus 40 for this guy. So this is an example of the exterior angle theorem. So what this says is if I take a triangle and I extend one of the sides out and I create these 4 angles essentially, 1, 2, 3, and 4, that angle 4, the exterior angle here, okay, is equal to the sum of the other 2 that are non-adjacent, the remote interior, angle 2 plus angle 1, okay? So how that applies here is that this 6x plus 20 is equal to the sum of these 2 other angles that are not adjacent to this one. Okay, so that's 4x minus 5 plus x plus 40. So I got 6x plus 20, we'll combine like terms to get 5x plus 35. We'll move the 5x over. We'll get x plus 20. We'll move the 20 over. And now we have x is equal to 15. And that's it. Okay, you can check it by plugging in and make sure the sums come out to the same thing. Okay, you were going to have a question like number 4 as well. On number 4, you're filling in the reasons here. So just remember how we normally do a proof. The first statement, the reason is always given. Okay. The second one, you want to go back and look at any keywords here. So I see I have right angle and I see I got the parallel lines. Okay. I also see that I'm proving the lines are perpendicular. So the perpendicular part should be pretty easy. It should be something with the definition of perpendicular lines or the lines intersect and form right angles, any one of those things. So why is it that this angle, WXY, is equal to 90? Well, in the given it says it's a right angle. So you can either just put down definition of a right angle or something about a right angle equaling 90 degrees, okay? Remember, you can use your angle symbols, equals, congruent, all that stuff. Just don't make up your own symbol, all right? You have to use one that already exists in the math world here. So now, second one, we know that this angle is 90. The question is, why is the angle next door to it 90? And it's because if these lines are parallel, right? These 2 lines are parallel to one another, okay? Then these angles are same side interior, which means they're supplementary. So this is also going to equal 90 degrees. So remember, any parallel line reason is going to start out with 2 parallel lines cut by a transversal. You're going to give me the vocab word that describes the angle. So here it's same side interior. It could be same side exterior. It could be alternate interior or exterior, okay? Angles. And then how are they related? So they're supplementary. And that's it for that one. And now we can describe lines B and D as being perpendicular because they intersect and form a right angle. So you can just say even something as simple as, well, that's the definition of perpendicular lines. You can say something like B and D, like I said, cross and form a right angle. Any one of those things is good to go. Okay? Number 5, a transversal intersects 2 lines. Which condition would always make the 2 lines parallel? Okay, so if I have this thing going on. Now, vertical angles are congruent, are always tied to the same intersection. So if those 2 angles are equal, does it make these lines parallel? And the answer is no. Because technically, I can make this line however slanted I want here, right? And it's not going to affect those vertical angles. It's not going to tell me the lines are parallel. So this one's out. Alternate interior angles are congruent. Well, that's true. That would be these and these, right? Corresponding angles are supplementary. No, these are also supposed to be congruent. And same side interior angles are not complementary. They're supposed to be supplementary. All right? So that would be choice 2. Number 6. In the diagram at right, lines N and M are cut by transversals P and Q. Which value of x would make them parallel? So we're going to assume that if these are parallel, right, what would have to happen for that to be true? I'd have to have like alternate exterior corresponding, alternate interior, any one of those things. Okay? So what we want to do is we want to use the angles that are here and ask ourselves, well, if this is 30, what other angle would also be 30 if the lines were indeed parallel? And it would end up being the one that's right down there. So this would also be 30 degrees. Okay? And then this 80-degree angle is also congruent to this angle because they're vertical. So now I have a triangle with 30 degrees and 80 degrees, which makes 110 degrees. And 180 minus 110 is 70. So if this was 70 degrees, and this has to be 80 because these are congruent, this would force this angle to be 30, and then that would make our alternate interior angles congruent. So we know that this answer will be 70. Okay? Number 7 in the diagram below. LMO is isosceles, another triangle symbol dropped off there. But LO grew to MO. Okay? If angle L is 55 and NOM, that angle is 28. Find the measure of angle N. So I'm going to put an X here for now. I can use X, I just can't use a letter that's already used in the question. So how do we do it? Well, we start off with noticing this isosceles triangle. If these two sides are congruent, the angles that are congruent are always across from the sides. So that means this side across from this angle, and this this angle across from this side. Okay? So that's 55, so is this guy right here. That's also 55, okay? And that's supposed to be 55, but it's pretty terrible. Now, we can figure out this angle, but we don't need it necessarily. What we really need is either this entire angle here, so we could use it, or if I just check out the fact that this is a triangle, as long as I know this angle, then I'm in business. And remember, this angle, LMO, and NOM, the one right next to it, should be added to 180 degrees. So 180 minus 55 would be 125, okay? All right. Yeah, so that's what we're going with here. So if this is 125 degrees and this is 28, then what's left for X? That's all we want to know. And 125 plus 28, that's 13, is 153. And then if we take 153 away from 180, because there's 180 degrees in a triangle, all right, we're left with 27 degrees. And that's the measure of that angle right there. And this would be your justification. There's your word shown. All right, I'll post the next 2 pages as a single video just to break it up a little bit, so that'll continue on next.